Hello, welcome to the BrainTech Mechatronics Engineering Academy. Now, before we start, I'd like you to understand what this academy is all about. Now, the BrainTech is an academy that will teach you everything about mechatronics. Now, there are courses on this website that will bring you to mechatronics and even advanced technology. Now, the first is the 8051 programming in assembly language, and then you have the components and analog device system on the stage 2. If you go to our website, you will see something like that. And the other one is the interface. Now the interface, which is the I/O interface, simply means input and output device interface. Now this input and output device interface will be showing you how you can interface all the sensors with 8051 microcontroller. So if you are building a project, you will not have to worry about interfacing any sensor, because we have broken down everything for you here to understand. Now, assembly language, if you ask me why I chose it, it is because it is easy to understand. Most people are complaining of C language and C++ because of this syntax and all those equation marks and all that in the language. So it is very difficult to understand, unlike Arduino, which is a very difficult microcontroller to deal with. Arduino is quite compatible, very nice microcontroller to study with, but I will bet you that 8051 microcontroller can do all the job, and Arduino, can do with C language. Now, the 8051 can be programmed with assembly language, it can be programmed with C language, and it can also be programmed with C++. I chose assembly language because this language is very easy to understand. Even an illiterate can start learning this language and will understand it. 8051 is very easy to understand. That is why I chose this language. So for this mechatronics course, we'll be using assembly language. Now, if you further want to upgrade your skill, it's on the website. After this training, we'll be uploading videos and tutorials on Python programming. And after that, we'll be going into machine learning. The machine learning in artificial intelligence using Python. Yeah, we'll teach you how to do all of that. But first, let's deal with mechatronics. Now, this mechatronics, we are using the 8051 microcontroller, and we are going to teach you how to program this microcontroller in assembly language, which has about 11 topics. Now let's go to the first topic. Now, as you can see, the first topic is introduction to computing. Now, lecture 1, introduction to computing. There are 3 parts in computing. One is the numbering and the coding system. You must have heard about numbering and coding system. Digital premium will explain about digital premium, which is telling us about the gates, OR gates, NAND gates, and all that. Now, inside the computer, what is inside the computer? The question we have to answer. Now, let's start with the first one, numbering and coding system. Now, the numbering and coding system, you must have done it in your O level. You know what numbering system actually means, the base numbers, binaries, hexadecimals, and all that. But in your O level, they didn't teach you about hexadecimal. That is the main purpose of this lecture. Here we'll teach you about hexadecimal because when you're programming a microcontroller, you are advised to use hexadecimal as a shortcut calculations in anything you are doing with 8051 microcontroller and other microcontrollers. Now, the numbering and coding system simply states that human beings uses base 10. Now, that base 10 is called what? Decimal. Arithmetic to count any values that are 10 distinct symbols, which are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Why computer uses base 2 binary system? They are only 0 and 1. And these 2 binary digits are commonly referred to as bits. Unlike your computer has 8 bits, your computer has 16 bits, 32 bits, and 64 bits. Same thing goes to the microcontroller. The microcontroller has 8 bits, 16 bits, 32 bits, and 64 bits. The 8051 makes use of 16 bits. The 16-bit microcontroller, but you can also use 16 bits. It's an 8-bit microcontroller, but you can also use 16 bits. Now, we'll get to that. Decimal and binary system. Now, we're going to do a little tutorial here, which says to convert from decimal to binary, divide the decimal number by 2 repeatedly, keep track of the remainder, continue this process until the quotient becomes 0. Write the remainders in reverse order to obtain the binary number. Now, these are the steps taken when converting from decimal to what? Binary. Now, converting from decimal to binary, let's take a brief calculation on that. You must have done this in your O level. I just want to refresh your memory. Alright, let's take this little calculation. Now, we are going to convert this decimal to binary. Now, this decimal is what? Base 10. Now we are going to convert it to binary. 25 divided by 2, you get what? 12, remainder 1. 12 divided by 2, you get what? Remainder what? 0. 6 divided by 2, you get what? 3, remainder what? 0. 3 divided by 2, you get what? 1, remainder what? 1. 1 divided by 2, you get what? 0, remainder 1. So, we are going to keep track of these binary numbers from the most significant bit to the least significant bit. So therefore, base 10 with decimal 25 will give you 11001. What? Base 2. Now, as you can see, the weight of these numbers are starting from 0, 1, 2, 3, 4. Now, 2 raised to the power 4 is what? 16. Times 1, 16. 2 raised to the power 3 is what? 8. Times 1, 8. 2 raised to the power 2 is what? 4. Times what? 0 is equals to 0. 2 raised to the power 1 is what? 1. Times 0, 0. 2 raised to the power 0, 1. Times 1, 1. Good. So now, I want to show you a little secret. If you don't want to stress yourself running all these calculations, you have to use what we call a scientific calculator. Now, this scientific calculator can actually calculate binary numbers, hex numbers, decimal numbers, octadecimal, and okay, I've mentioned binary numbers. Alright, now let's see if this answer is really correct with this calculator. Please take note, you are advised to download this calculator from Google Play Store, which is called the Hex Calculator. Go to Google Play Store, you can download it on your Android device. It is very important. If you study mechatronics and you want to start building projects, or you want to start doing school projects, or you want to go into selling of commercial projects, your scientific calculator is very important. It will make you to save you time from running calculations with your head and all that, and running big values. So this calculator can actually calculate hex. So now let's see if these numbers are correct. So we have what? Binary. The binary is what? 11001. Convert it to hex, you get what? You get what? 19H. Now convert it to decimal, you get what? 25D. Convert it to octadecimal, you get 31C. 31O. But in this 8051 programming system, we are using only hex, decimal, and binaries because they are 8 bits to 16 bits. 8051 is an 8-bit microcontroller, but you can manipulate it to get 16 bits when you combine registers together. In the program, we'll teach you how to do that. But for now, it's good for you to know how to calculate this thing with your scientific calculator. Instead of stressing yourself using your head to calculate these things, just use your scientific calculator. Hexadecimal system is a 16-bit system. Now, the base 16, the hexadecimal system, is used as a convenient representation of binary number. Now, instead of you to write bulky binary numbers that are very long, just use your hexadecimal system by using your calculator to convert it. As you can see in this tutorial, look at how they converted these long values to what? Hex. Look at it, it's very short. And this hex value can be uploaded to any microcontroller, be it Arduino or 8051 microcontroller. To do what you want to do with ease, instead of writing this is actually stressful. That's why this hexadecimal system is very good. It is good for you to learn it, know how it works. Now this is a table of hexadecimal system. If you want to learn the conversion of your hexadecimal system, you have to use this table. As you can see, they are converting this number to hexadecimal. Now they actually did it manually. Because in hexadecimal system, it is collecting 4 bits each from the binary system. Now your hexadecimal system is a 16-bit system, which is base 16. So now we are taking 4 bits each. Let's convert this number to hex. Now look at how long this number is. Very complicated. Now you can't be writing all this kind of thing in a microcontroller, so it's better you convert it to hex. So convert it to hex, you get 9f what? 9f what? 5. Now this is it. 1001. Now this 1001 is the first 4 bits. Now let's go to the table. This is it. 1001. Which is what? 9. Second one is 1111. 1, which is 15. This is it. Now this 15 is what? Decimal, but the hex is what? F. So you come here, write F. Now the third one is 0101. Now this is it. 0101, which is what? 5. So you come to this place and you write what? 5. So you can see how short it is. Now let's confirm this if this is actually true. Now you use your scientific calculator and type the binary system. Now this is the binary system. 1 0 0 1 1 1 1 1 0 1 0 1. As you can see, it's absolutely correct. So this number is very complicated. Instead of using binary system, use hexadecimal system. Very sweet and lovely. When sending data and receiving data to any microcontroller, the hexadecimal system is advisable to use. Now to convert from hexadecimal to binary is very simple. You still have to make use of your calculator. So you have to play with this a little, play with it, and you get to understand how it works. Meanwhile, we go to the next heading, which is digital premium. Now digital premium is trying to tell us in digital electronics, 2 voltage levels can be represented as the 2 digits 0 and 1, which means high and low. Now the 0 is known as the low signal, while 1 is known as the high signal. Signals in digital electronics have 2 distinct voltage levels with built-in tolerance for variation in voltage. Now these voltage levels are 0 volts and 5 volts, because in a microcontroller you use 0 volts and 5 volts. At 0 volts, I think the microcontroller should be off. At 5 volts, the microcontroller should be powered. That is what they're trying to tell us here. And what microcontroller understands is 0 and 1. Either you're sending binary 0 and 1, or you're sending decimal, or you're sending hex. Don't worry, with time we'll get to understand as we do more programs. So now here is your logic gates on that digital primer. Now these logic gates, I'm going to explain one for you so you understand how it works, though it is not needed at this stage, but as we go further you get to understand it by yourself. Yes, it is not needed, it's just for you to know how it works, you understand? This is for usually for advanced electronics, but this is the first stage, which is what you just have to know what they call logic gates, your AND gates, you know, and OR gates, NOR gates, and all that. Now the logic gates are actually plenty, which is number one is the AND gate, the OR gate, the inverter gate, the XOR gate, NAND gates, and NOR gates. Now these gates are called logic gates. They are digital signals that is manipulated to get your value X. Now on AND gate, is X is equal to A dot B. Now AND gate simply tells you a true or false table. Now the true is equal to what? 1, and then the false is equal to 0. Now in AND gate, if A signal is what? 0, and your B signal is 0, AND gates will be equal to 0. In AND gate, if your A signal is 0 and your B signal is 1, AND gate will also be equal to 0. This is more like an expo. This thing is trying to tell you that once you get to a stage where you'll be using AND gates, you can just come here and collect the formula. This is not a calculation or whatever. This is just an expo. It's an expo for you to understand how it works. It's just a formula this is you're seeing is a formula. Take note, it is not a calculation. They are all formulas, so that when you start dealing with conversion of ARCHI code at the ending of this stage 1 of mechatronics, that is the programming of 8051 microcontroller in assembly language. When you start dealing with ARCHI code, you can just come here and pick up the formula, because there are some places you see it will tell you to convert using AND gates, convert this to this. So you have to come here and pick up the formula. And you know in AND gates, if A is equals to 0 and B is equals to 0, X will be equals to what? 0. So, alright, so if you were asked, what is inside the computer? What are the units of data sizes in a computer? Here is the answer to that question. Bits. A binary digit that can have the value of 0 and 1. Remember I said bits. Bits are 0 and 1. Understand? That is the language computer understands. Computer does not understand English. What it understands is 0 and 1. So you have to convert this 0 and 1 to what we call ARCHI code. Now that ARCHI code is the American standard coding system. So that is where English now falls in. So if your computer is to understand English, everything has to convert to ARCHI code. But what your computer normally understands is 0 and 1. Every computer system, both the microcontrollers and all things in computer is 0 and 1. Now bytes are called 8 bits. Labels are called half a bit. Okay, there's an error here. You have to correct it yourself. Labels are called what? Half of a byte. Half of a byte is what? 8 bits, and the half of it is 4 bits. Half of a byte is 4 bits. Sorry, because a single byte is what? 8 bits. So half of it is 4 bits. So now, as time go further, you understand how to program this 8051 and know how to convert these systems. You get your 16 bits, 8 bits, and all that. Now, the terms used to describe the amount of memory in IBM PCs and all forms of computer. These are the terms used to describe the amount of memory in IBM computers. Now, these IBM PCs are the modern PCs we use in these 21st centuries, and even before now, they have been using it. So this is how it is being rated. We take note. Internal organization of computers. Now, the first part is what? The CPU, Central Processing Unit. Now, this Central Processing Unit is called what? If you're being asked, what is the CPU? What does it do? In a short form, very simple. You don't need to go deep. It is used to execute information stored in memory. Now, another internal organization of computers is what? The input and output device. It provides a means of communication with the CPU. The input and output device, like I said, in 8051 microcontroller, during the practicals, this input and output device provides the means of communication with the 8051 microcontroller. So you can see the same thing is applicable to the CPU in a computer system. So now the third one is the memory. Because you all know, you have been taught in your O level. This is your memory, which is your RAM and ROM. Now the RAM, random access memory, temporary storage of programs that computer is running. Now these are the temporary storage, which means data can even get lost. When your computer is turned off, it will disappear. So now the second one is the read-only memory, which contains programs and information essential to the operation of the computer. Very powerful. This one is inbuilt. If you switch off your computer, it is still there. Just like saving a file, a PDF file, a PDF document, it is still there. So that's how your ROM works. The same thing with 8051. You can save data in 8051 and come back next 5 years to come and check what you saved in that 8051 microcontroller. So now note, the information cannot be changed by use, and it is not lost when the power is off. It is called non-volatile memory. Wow, very powerful. So now look at this is a block diagram of the CPU connection system. That's the internal organization of computer. This is a block diagram. So now this is your CPU, this is your address bus, this is your data bus, this is your memory, RAM, ROM, peripherals, and monitors. So now note, the CPU is connected to the memory and input and output through strips of wire called bus. Now that bus is called a strip of wire. Now data bus and address bus will be explained on our YouTube channel. So now let me explain this data bus and address bus. Now when you're sending data, to a CPU, maybe from a printer, a monitor, a mouse. You want to connect it to the CPU, like you want to connect a sensor to the CPU. Now, the wire you use in doing that. That wire is called bus, and what that wire is transmitting is known as the data bus, because data is flowing through that wire. Now, that thing you should understand. You can't just transmit data into the CPU without giving it a location. That location is known as address bus. You must assign your CPU a location where this data bus will enter. You must assign what? A location to your CPU where this address bus will enter. The same thing with 8051. You have to assign a location where your data will go to. The same thing they do on Arduino, the same thing they do on other varieties of microcontroller. So you have to assign an address which is called a location. Yes, you're going somewhere and you're carrying a data. You must surely have a destination, so that's what is called address bus. Now, what data bus is the data you're carrying to go and deliver to the location that the address bus has provided for you. Take note. Now, what is inside a computer CPU? Now, this one is called the registrar, the ALU, program counter, instruction decoder. We'll take them one after the other. The registrar, you know what it means. This is it. The CPU register is used to store information temporarily, which means values can be processed and address of the value to be fetched from memory. In general, the more and bigger the register, the bigger the CPU. So you can see what is really actually inside the CPU, what makes it function. So in 8051, you'll be making use of registers too. Yeah. And in 8051, you'll be making use of arithmetic and logical units. Arithmetic and logical units. Okay, this is number 2, arithmetic and logical units. The part performs arithmetic functions such as add, subtract, multiply, divide, and logical functions such as AND or NOT. Now, this arithmetic and logical unit is a mathematical system that has been provided for a CPU to understand. That is what is inside the CPU. Now, nothing that is inside the CPU is a program counter. Now, this part calculates the address of the next instruction that will be executed. As you're executing the instructions, the program counter is counting it. It's pointing to the address, and it is incrementing. As it's incrementing, the space is getting filled up. You understand? So now this is an instruction decoder. Instruction decoder. This part interprets the instruction first to the CPU. The CPU is capable of understanding more instructions required. Let's take it again. An instruction decoder. This part interprets the instruction first into the CPU. The CPU, capable of understanding more instructions, requires more transistors. To design. Don't worry, in your electronic components, you should know what transistor means when we get there. So this is the end of the tutorial. I hope you actually understand how all the system works. Now we are through with lecture 1 tutorial 8051 microcontroller programming in assembly language. So guys, thank you for watching. You might want to subscribe to my YouTube channel by clicking the button below, so when next tutorial comes up, you will get notified by YouTube.